Well, gang, I hope you're ready for some epic roaming because that's where we're at right now. What we're seeing here is an environment where we have, again, an expectation of a couple of buildings, all right? But they are all networked together. But, of course, we have a set of switches that and they have been defined as a switch peer group. We have another set of switches, a separate switch peer group. Those switches are 3860s I'm sorry, 3850s or 3650s. So they've got the converged switch element. They've got the wireless LAN controllers built into them. We've got all these access points connecting so that we can roam and we can roam. But what if we want to roam between buildings? Well, now we're talking about something where I would expect there to be a different subnet when we move from one building to another. That's normal. But here's the deal. I don't want this client to have a different subnet because they're on a voice call. And if you change your IP address midway through a voice call, it drops the call every time. So, things to keep in mind. At this point, we have the point of presence on this particular mobility agent, and the point of attachment is the same because this is where I've begun. This is connected up into this infrastructure, and we have a centralized mobility controller. This may be, for example, a 5760. All right, so that's our environment so far. Now, we have a mesh between all of our mobility controller devices here within each switch peer group, but I need to roam between the groups, right? Roaming between the groups and roaming between VLANs. So here's what happens. Now the device has moved and it's over in the other building, right? So we've seamlessly moved from one building to another. Was it really seamless? Yes, and here's why. Even though at this point, this client has now attached to this particular access point. And this access point is ready to give that client an address within the local VLAN that makes sense for clients over here. The reality is that although it has recognized that, that is not what it's actually going to do directly. See, normally what we would have is a CAPWAP tunnel endpoint and the client would be seen right here if this was a standard environment. But it's not standard in that we have mobility running. And with mobility running, this particular mobility agent double-checked with its good buddy, the mobility controller. And the mobility controller says, oh yeah, I know this guy. He actually had his point of presence over here in this VLAN off of this wireless infrastructure. So what I'm going to need you to do, mobility agent, is I'm going to need you to actually encapsulate this client's data, send it over the network using whatever VLANs you use to communicate out on this LAN. We're going to send it all the way over through the infrastructure, right, through distribution down to the core, and get here to the mobility agent and the controller where that client originally attached, its anchor point. And then that particular device will de-encapsulate and then allow this client to have its point of egress, its IP address, and everything else be hosted through this point of presence. So even though the point of attachment is remote, the point of presence is still the same, and we can encapsulate our data so that the layer 3 information and the IP address that I would have over here can be encapsulated within the IP address that is used for communication over here. We're going to use the CAPWAP tunnels that are going to be established in order to maintain this. Again, this is all possible because all of these devices are part of the same mobility domain. They're all aware of the same mobility controllers, and therefore they can communicate this information. So this is going to be how a client is able to actually roam even into different switch peer groups, into different mobility groups, even into different subdomains, right? All those different boundaries change the reaction time, if you will, some. But the fact is we can move and we can cross layer 3 boundaries with ease because of encapsulation and because of the common knowledge that is maintained through the mobility controller conveying information to the mobility agents. Voila.